So, what if we could teach an AI to see a picture not as a boring old grid of pixels, but as a living, breathing, interconnected network? Well, today we're diving into exactly that. It's a completely new way for AI to make sense of the visual world.
I know, it sounds a little weird, right? I mean, images are photos, and networks, well, that's stuff like your social media feed or maybe a subway map. But what happens if you smash those two ideas together? Could you create a smarter, more intuitive AI? That's the big question we're tackling.
All right, here's our game plan. First, we're going to explore this whole new way to see. Then, we'll get our hands dirty and turn an image into a graph, step by step. After that, we'll build the AI brain that can read it, watch it learn in real time, and finally, we'll get to the bottom line. Did it actually work? Okay, let's kick things off with a totally new perspective. A traditional AI looks at a picture like a giant piece of graph paper, just a massive grid of colored squares. And yeah, that works, but it kind of misses the forest for the trees. It doesn't really get the context, how all those little squares relate to each other. We're about to go way beyond that.
So I want you to imagine something. Instead of a flat grid, picture an image as a sprawling city. It's made up of all these different neighborhoods, right? And connecting all those neighborhoods are streets. This one simple idea, neighborhoods and streets, is the key to understanding this entire process.
Now for the really fun part. How do we actually take a normal photo and turn it into this city map? This section is literally the blueprint for taking an image, say of a sheep, and transforming it into a network that an AI can actually navigate. And you know what? The process is surprisingly simple. You just start with your image, then you chop it up into a bunch of little 32 by 32 pixel squares. Each one of those squares becomes a node. That's our neighborhood. And then you just draw lines connecting all the adjacent neighborhoods. Those are our streets. And just like that, boom, a flat picture is now a rich, complex network. Of course, to make sense of this new city map, you need a special kind of tour guide. It's called a graph neural network, or a GNN for short. See, unlike other AIs, a GNN is built from the ground up to understand network data. It doesn't just look at the neighborhoods. It pays really close attention to the streets, the relationships between them. Okay, so we've got our data all mapped out. Now we need the actual brain that can think in this new way. So let's pop the hood and take a look at the architecture of our specific model, which is a flavor of GNN called a graph convolutional neural network. The model itself is called the Livestock GCNN. As you'd expect, it takes our image graphs as its input. But the real magic, the heavy lifting, happens in these three core layers. This is where a super cool process called message passing goes down. And once all that's done, a final output layer makes the call. Is it a cow, a sheep, or what? And this brings us to the secret sauce of how it learns, message passing. And honestly, it's just like it sounds. It's like gossip spreading through a town. Each neighborhood tells its immediate neighbors what it's seeing. They pass these little messages back and forth, and through this constant conversation, the AI starts to build a complete picture of the entire image, not just a bunch of isolated parts. All right, the brain is built, the textbooks are ready, it is officially time to send our AI to school. In this section, we're going to watch the training happen and see if this whole network idea actually helps the model learn to tell different animals apart. So, the training plan is to run for 25 epochs. Now, an epoch is just a fancy word for one complete pass through all the training data. So basically, our AI gets 25 chances to study all the images, make a guess, see if it was right or wrong, and hopefully get a little bit smarter each time. And check this out. This shows you the learning in real time. At the very beginning, in that first epoch, the model's accuracy is pretty rough, barely better than a coin flip. But then, just look at the jump by the 8th epoch. We're already over 70% accuracy. The model is clearly starting to pick up on the patterns in those networks. It's working. Okay, we've seen it hit the books and start to make some real progress. But what about the final exam? After all 25 rounds were done, what was the final score? It's time to look at the results and answer the big question. Was this experiment a success? Well, the proof is right here in the charts. On the left, you can see those accuracy lines just climbing steadily upwards. That is a beautiful sight. That's exactly what you want to see. And on the right, you've got the loss, which is just a measure of its mistakes, and it's consistently going down. Less error means a smarter model. This is, without a doubt, a picture of successful learning. And if we boil it down to the final numbers, here's where we landed. The model peaked at about 76% accuracy on the training data, and more importantly, around 73% on brand new data it had never seen before. That is a solid result that tells us this whole approach is definitely on the right track. So here is the big takeaway, the most important thing to remember from all of this. The model didn't just learn to see pixels, it learned to see relationships. It figured out how to identify an animal by understanding how all the little parts, the head, the legs, the tail, connect to form a whole. And that is a huge leap forward because understanding context is what AI needs to tackle really complex problems, from medicine to self-driving cars.
And all of this leaves us with one final fascinating thought. We just took a flat, simple image and turned it into a dynamic network to give an AI a whole new way to see. It really makes you wonder, doesn't it? If an image can be a network, what else out there are we looking at all wrong? What else can we start to understand in a completely new way?